So this is a simulation of a Z80, obviously. Well, it's an emulation. It's an emulation of a Z80. We've got a picture of a Z80 here, and I'm just using TK and Python to show the state of the pins. The address pins, data pins, got the clock. I've even put that we've got 5 volts on the 5 volt pin and 0 volts on the ground pin. So yellow is 0 volts, green is 5 volts. The pins have got arrows on them showing the direction, either outputs or bidirectional for the data ports. Input for the clock here. So the clock's the only pin I'm controlling kind of directly. The memory, the chip is reading from memory, so I guess I'm controlling the input of the memory as well when it reads from memory. So I was kind of inspired to make this after viewing a few years ago now Julian Illitt's breadboard Z80. But just by simulating it, I get a chance to use more of the to easily show more of the pins, I suppose. So what do we got going on? So these are two outputs from the Z80 that tell it what kind of memory fetch or write it is doing. Well, no, fetch, I suppose. So M1 tells us that it's the operation, the operand that it wants to load. So load or increment or jump. And when M1 isn't low, then it's either a refresh read or it's loading the, I don't know what you'd call it, the bytes that come after the operator. So in this case, this command is jump to memory location number 3, and this one is load HL with number 0D. So I've decoded the address that it asks for, and here's the program, and I've set it to highlight the byte of memory that it's currently reading. So you see orange there is for reading a command. The red that we just saw there was it writing to memory. So every time M1 goes low, you'll see orange. There we go, orange. And here are the write and read flags that the CPU puts out. So when write goes low, then that's when the red shows, because it's writing to memory, and then when read goes low, it's either going to be orange or yellow. There's yellow there, because it was a read, but it wasn't an M1 operation. When refresh goes low, then it's just reading the memory just to keep the memory, the dynamic memory, remembering. It's not showing the refresh at the moment because I think the refresh address is too far. What is it? It's about 16 and it goes off the end there. So if I just do a reset, so the reset you do by pulling the reset pin low, and I'm just going to simulate that by pressing here. See the reset pin's gone low. I know the only thing that's working is the clock, and then when I clear the reset, everything starts up again, but it starts up at 0, and you saw that the first read was blue there, indicating that it's was a refresh. It only does the refresh after the operand read. It doesn't do it after the supplementary byte read. Oh, I did not know that. What else have we got here? I can do a bus request. So the bus request you can do by pulling this pin low, and then you wait for a bus acknowledge. So typically the processor tries to finish the command it's on. I should do it now. Bus request, now it's on this command, it'll do its next read as well. Oh no, it didn't. That's interesting. No, it didn't. It managed to stop halfway through. So when I clear So you see bus acknowledge has gone low as well to tell me that I've got the bus. So now when I do clear the bus request, it should finish off that command. Yeah, well, that's interesting. I didn't think it would do that. I thought it would completely finish the command it was on. It's able to stop mid-command. Very interesting. Let's do one more of those for fun. There we go, clear it. I'll do one more because I missed the bus acknowledge. So there's bus request, and there's the acknowledge come, and now I'm in charge of the bus. Now I've left it showing that it's wanting to read this address, but really, in reality, these have gone to high impedance. I probably pronounced that wrong. High impedance, and but I haven't coded that up. Same with the data bus. We've also got halt. I haven't coded that yet, and we've got the two interrupts. Would be rather fun to code up as well. The normal interrupt and the non-maskable interrupt. So maybe I'll do that at some stage. Anyway, I had fun doing that and thought it would be an interesting thing to share.